Okay, so we've been talking about functions, which is a special type of relation where the domain or the x values don't repeat. And we've been talking about relations and functions. We can show them using ordered pairs. We can show them using a graph. We can show them using a table. We can show them using an arrow diagram. Now, most of the relations and functions we're going to deal with, if not all of them, involve numbers. Okay, when we first started, we were using words and letters and sometimes numbers. Now we're just going to focus on numbers. And another way that you can show a relation or a function is using an equation. Okay, an equation that has two variables in it, because remember, a relation is two sets of information. An equation with two variables in it has a set of information x and a set of information y, or whatever letters we want to use. So when we do a function, or actually before I do this, I'm going to do this. So in the previous example, okay, if you look at that table with hours worked, and gross pay, we could make an equation out of it. And the equation we could make is, if we call the gross pay P, how do you calculate your gross pay? If you look at the table, for 1 hour work, they get $9.50. 2 hours work, they get $19. 3 hours, $28.50. How much are they getting an hour? $9.50 an hour, right? So we want to make that into an equation. To find their pay, I take whatever number of hours they work, 1, 2, 10, 12, 15, and multiply it by 9.5. So that's an equation for that function. I take the first set of information hours, whatever numbers those are, times it by 9.5 to get the second set of information, the gross pay. Okay? This is what we call relation notation. We can also show it using function notation, which is slightly different, but means the same thing. Okay? So think of a function like we're taking some set of information, x, doing something to it, a function, which we'll call cursive f, and then out pops y. Or we actually call this f of x. That's pronounced f of x. In this question, the information we are inputting is h. Okay? Then we are performing something inside to calculate gross pay, and out pops P of h. And again, that's how you read it. Don't think of it as, it's not multiplication. It's not P times H. It's P of H. So another way that we could write this equation is like so. And that is called function notation. These two mean the exact same thing. It's just this one is called a relation, and this one I can call it further a function. That's all. Okay? So it's just a new type of notation we're going to use for equations. So let's say we want to use this equation and we want to figure out, okay, how much pay for 25 hours worked. In other words, we want to find the pay at 25 hours. So to find the pay at 25 hours, all I do is plug 25 in for H. So instead of 9.5 times H, it's going to be 9.5 times 25. And then you calculate that, and can't do that off the top of my head. Does that give us $237.50? Okay. All this is a new type of notation. So for example, don't overthink this. If I have the equation, I don't know, T equals 2.5 times N plus 3. That's relation notation. How do I convert this to function notation? Instead of T, I write T of whatever this variable is. The right side stays the same. That's it. That's all you do. This is relation. This is function. FCN is short for function. So if I gave you this, let's say, I don't know, M equals lowercase m equals P divide 5 minus 1. How would I write that using function notation? Don't overthink. What would I change? Yeah, all I do is change this to M of P. This is relation, this is function. There's one special case. Whenever we have an equation that has X and Y in it. So for example, Y equals 3X minus 2. That's relation notation. Now you would think to change it to function notation, we would just go, oh, Y of X equals 3X minus 2. But we actually don't do that. Whenever we have Y, we always change it to F of X. Okay, Y always changes to F of X. That's the only exception. Otherwise, T and N go T of N. M and P go M of P. That's it. Okay. So let's look at a couple of examples. Okay, so here we have an equation, and this is in relation notation. It's in relation notation. And what does it represent? That the volume of gas remaining in a vehicle's tank after driving this many kilometers. So if you drove 100 kilometers and you want to find out how much volume or how much gas you have left in your tank, you do negative 0.08 times 100 plus 50. Okay? Don't worry about this described function.
how would you write this in function notation? What would you change? Yeah, you change the V to V of D. That's it. And we can use this equation to answer some questions. So we want to find V of 600. What does that mean? That means D is 600. So I am asked to replace D with 600. And then calculate. So if you do that on your calculator, negative 0.08 times 600, and then you add 50. Sorry? Just 2. What? Oh, 2. Oh, sorry, you're giving me the. Okay. Yes, that's right. 2. But what does that 2 mean?
After driving 600 kilometers with 2 liters of gas.
Right. When you drive 600 kilometers, 2 liters of gas left. That's what that means. Another type of question you could be asked. Find D when V of D is 26. So we're not replacing D, we're replacing the whole thing. So we're replacing V of D with 26. And we've got to figure out what D is. So how do we solve this equation? Yeah. Subtract 50. Subtract 50. And I get negative 24 is equal to negative 0.08 times D. Divide both sides by negative 0.08 to get D by itself. And D works out to what, 300? And remember, D is distance driven, so that's 300 kilometers. So with this vehicle, if there's going to be 26 liters left in the tank, that means you must have driven 300. Okay. Let's look at one more. Do you have this?
Yes.
Okay, good. Because I added this question. So we're given the function f of x equals 3x minus 7. How can we tell its function notation? Because the left side looks like that. I want to find f of 2. What would I do?
F2 equals 3, 2, and 7.
Yeah, all I would do is plug 2 in for x and calculate. 3 times 2 is 6. 6 subtract 7 is negative 1. For B, notice I'm not replacing x. I'm replacing f of x. So I'm not putting 8 here. I'm putting 8 here. And when I do that, I make an equation. How do I get x by itself? Algebra. Add 7. Add 7. Divide 3. X equals 5. Good.
So there's really nothing new here. The only thing new here is the notation we use. We've done questions like this before. Yeah.
Who put the y in again, we have x, I have x equals 5 and the y equals 8. Substitute it for.
No, no.
Okay?
Okay.
So that's the second